Hi, it's Mr. Anderson, and this is AP Physics Essentials, video 117. It's on beats. Beats are changes in amplitude when you have two waves that have a frequency that's very close together. And you can actually play around with this if you're connected to the internet. And so I'll put a link to this down below. But if you go to this website right here and you launch it, what you can do is you can play a tone. And so what I'm going to do is play one that's at 440 hertz. I'm then going to launch another tab, and in that tab I'm going to briefly change what note I'm playing. So that's 440 hertz. That's also 440 hertz, but listen what happens when I change one of them. Those are beats. Now they're gone. Now as I go above it, you can hear the beats again. And as I bring them back to the same value, then it goes away. Now, when would this be useful? Well, let's say you're tuning your guitar. What you can do is tune one of the strings. So make sure you tune that to a tuner or a piano or something like that. Once you have that, then you can play another string. You have to move up on the fret, but play another string. And if it's close, you'll hear the beats. And if it's exactly the same, you can adjust the one, then the beats will go away. And then you can move on to the next string and the next string and the next string. And so waves, when they come together, will interact. And as they interact, they cause interference. Now that interference can be constructive, sometimes building up the wave or the summation of the waves, and sometimes it's destructive, it's tearing it down. But if those waves are very similar in frequency, what you get are these beats, and beats are going to be amplitude changes. In other words, the volume is going to go up and down and up and down and up and down due to this constructive and destructive interference. Now it's really easy to calculate the frequency of the beats. All you do is frequency of the beat equals the absolute value of the difference between the two frequencies. So if I know frequency 1 and 2, I simply subtract 1 and it's the value, absolute value of those. And so again, in review, if you don't know what constructive and destructive interference are, if we have two waves that are perfectly the same frequency and they're right next to each other, what we'll get is constructive interference. If they're out of phase with one another, we'll have destructive interference. But if the frequencies are slightly off, and if we look at this animation down here, these are frequencies that are close but not exactly the same. What you get is, as you have this constructive and destructive interference, you get the blue summation of those two waves, and you can see that we're seeing these changes in the amplitude. In other words, the amplitude is decreasing, then increasing, and then decreasing. Now, if I could make those frequencies exactly the same, then the beats are simply going to go away. How do you calculate it? Again, it's frequency 1 minus frequency 2, absolute value of. And let's do a sample of that. So I'm using Audacity. It's a little music software. And so what I'm going to do is I'm going to generate some tones. And so I'm going to generate a 440 hertz tone. So that'll be in one track. And then I'm going to add another track down here, and we're going to generate another tone. So we'll make this one slightly different. It's 440 hertz. Like that. Now let me mute the bottom one and play the top. And now let me mute the top and play the bottom. So they sound almost the same, but let's play them together now. So we'll unmute them. So now you can hear those beats or those changes in the amplitude. Now let's calculate what the frequency of the beat should be. So frequency of the beat is going to be F1 minus F2. And so what were the two frequencies? Well, we had 440 and 444. And so if I put those two values in, what's my frequency of the beat going to be? It's simply going to be 4 hertz. So now let's check that with this model. And so what I'm going to do is now mix these two together. And we're making a single track of the two. And now let me get rid of those first two tracks. You can already see the beats. And now let's check our numbers. So let's look at 1 second in time. It's exactly 4 beats. The frequency of the beats equals the difference between the two frequencies. So did you learn to use a visual representation to explain how slightly different frequencies cause beats? I hope so, and I hope that was helpful.